So today I'm going to talk about the generalized linear model, and let's start with the example. Okay, uh, so mm, uh, so there's something called kyphosis. Kyphosis is a kind of like a feature of um, feature of the people whose back is hunched. Is a hunchback. Okay, and in a medical world, you take a baby, and take a baby. Take a small baby and measure its different attributes, height, weight, all kinds of attributes, and predict whether the baby will become a hunchback later in his life. So these are all X1, these are all features of the baby. Okay, and so they form a vector. They form a vector, and then what we're gonna do is that what we're gonna do is use this feature to predict which is a binomial, binomial that whether baby will be a hunchback or not later in his life. It's a binary. Okay, it's a binary. So when we so this is a process. This is a process called prediction, and what we're gonna do now is that so we take we do we take we won't just measure one baby, but we do measure thousands of babies, and take use this as a expectation, like whether this kind of attributes produces this kind of prediction of the being hunchback. We do assessment of the thousands of hunchbacked people, and use the feature at the when they were child to do like a mapping of prediction, whether like a given these predictions, given these are the future vectors of the baby, and they actually are hunchback later in their life. So so let's since being so so being y is a whether hunchback or no, given a particular x, uh, a particle x being a small x, we say that okay, this is an whether it is either is hunchback or no, based upon whether x is a certain small x. Okay, so what happens here is that like whether x1 is small x1, x2 is small x2, and x3 is small x3. So this is basically a mapping. If these feature vectors mapped into x1, x2, and x3, then yeah, this either is hunchback or no later in life. So the expectation of this would be would be mu x, and it is basically expectation of y given small x, and this is called and this ranges between 0 and 1. Ranges between 0 and 1. This is called expectation of x. All right, and this is called expectation of x. And so when we try to so what we now need is what we now need is a function that would invert that would invert the function 0 1 to a real number. Now we needed something that would um, that would change back the 01 to a real number. And for that what we need is a function called g, which takes this function, which takes this mu x as a as an input parameter, and produces um, something called a real number. And this is a real number that ranges from minus infinity to plus infinity. And this g, which is an invertible function, it is called g, or g function. It is called this, and this g function is called a link function. This g function is called link function. Is called a link function, and we use that function to map the mu x into a map the mu x to xtb, which ranges from minus infinity to plus infinity. So here's an example of a link function, right? So let's take this line, and these two lines, and you have this x-axis here, x-axis here with the 0 and 1 in the x-axis, x-axis, and this goes from like this, and y goes from the and y goes from and y goes from minus infinity to plus infinity. So this is the xgb xgb, and this is mu x, and this x itself is called mu x, you know. And this is how you do the link function, where it maps the value between the 0 and 1, and to the minus infinity to positive infinity. And this is how you do the link function in the generalized linear model.